Thank you very much, Tabitha. I'm Pete Clutton-Brock, as Tabitha mentioned. I'm the director of Hinge consultancy, which focuses on climate change and technology. I'm also the director. I'm also the concept lead behind the International Centre for AI, Energy and Climate Change, a concept that we're putting to the UK government. The purpose of this session, as Tabitha said, is how to accelerate the adoption of AI for climate change. And inherent in that question are two things. One, that there are worthy applications of AI for energy and climate change that we need to be accelerating. And two, that we need to be actually focusing on what the barriers are and how to overcome those, and from a variety of sectors. So now I'm going to introduce the panel that we have to address these questions. We have an excellent panel. The first person I want to introduce is Priya Donti. Priya is a PhD student in computer science and public policy at Carnegie Mellon University and the US Department of Energy Computational Science Graduate Fellow. Her work lies at the intersection of machine learning, electric power systems, and climate mitigation. Specifically, she focuses on creating novel machine learning techniques that incorporate domain knowledge to reduce greenhouse gas emissions from the electricity sector. She is also the co-founder and co-chair of Climate Change AI, an initiative to facilitate impactful work at the intersection of climate change and machine learning. We also have Paul Massara. Paul is a chair, non-executive director and advisor and investor in a number of energy tech companies, including iSize, Zygo, and Electron. He is also chair of the Sovereign Housing and Medicinema. He is a member of the Fuel Poverty Committee at Bayes and also an associate of Creative Destruction Lab in Oxford. He is also working with me on a proposal for the International Centre for AI, Energy and Climate Change. And finally, we have Baroness Bryony Worthington, who is a crossbench member of the House of Lords, having spent a career working on conservation, energy and climate change issues. Prior to her appointment as a peer in 2011, Baroness Worthington worked at Friends of the Earth on their Big Ask campaign, which successfully lobbied for the introduction of climate change laws, and she played a seminal role in the introduction of the Climate Change Act in the UK. From 2016 to 2019, she was the executive director of the Environmental Defence Fund in Europe. Her current roles include co-chairing the cross-party caucus Peers for the Planet and devising grant-making strategies for Quadrature Climate Foundation. So thank you all for joining us. So this session, as I mentioned, is on how to accelerate adoption of AI for climate change. And the overall introduction to CogX as a whole is how do we get the next 10 years right? And that question couldn't be any more relevant for the issue of climate change, because by 2030, we effectively need to have halved global emissions. So to put that into context, the COVID-19 crisis has reduced emissions by what is likely to be about 5.5% in 2020 compared to 2019. We need to reduce emissions by 77.6% year on year to achieve the 1.5 degree goal set out in the Paris Agreement. So no small feat. And in that context, we need to be thinking about exponential technologies that can drive the emission reductions that we see at an exponential scale, not on a linear one. And the interest and the opportunity that we have for applying data science and AI to a range of challenges across the energy and climate change spectrum is increasing, and the awareness about the opportunities is increasing. At the same time, there are also a series of barriers that make it harder than it should be to apply some of these technologies. These can be policy barriers, data barriers, finance barriers, barriers of coordination, and siloization of experts. Now, I'm going to ask all of the panelists to offer their perspectives on how we can accelerate the adoption of AI for climate change and address some of these barriers. This is also a question that I've been thinking about personally, as I mentioned, in developing an international centre for AI, energy and climate change to address some of these concepts and barriers at scale. More on that later, but to start with, I'm going to dig in with the opportunities and ask Priya to maybe cover us off with thinking about how we can describe the key opportunities there are for applying AI to energy and climate change challenges. Priya.
Hi, everyone. Pete and organizers, thanks so much for having me. So as Pete mentioned, I am part of an organization called Climate Change AI, whose goal is to facilitate meaningful work at the intersection of climate change and machine learning. And as part of that, we wrote a 100-page report called Tackling Climate Change with Machine Learning, that details many of the ways that machine learning can be used with high leverage to reduce greenhouse gas emissions and also help us adapt to a changing climate. So I'm going to give an overview of some of the areas covered in that paper over the next few minutes, but I would also recommend to anyone in the audience who's interested to check out that full report. So in that paper, we dive into the various ways that machine learning can be used in a variety of sectors, so electricity, transportation, buildings, to help decision makers with adaptation. And there are some major themes that emerge from the machine learning technical side of things. One of these is forecasting. Oh, you're getting choppy audio from me? Nope. Okay, I will keep going. Okay, so one of these themes is forecasting. So trying to draw on historical data to make predictions about the future that then inform decision making. And this comes up in a lot of different areas. For example, trying to forecast crop yields in the future and how those will be affected due to climate change, or trying to forecast extreme weather events in order to help adaptation policies. But one example I'll dig into here is solar and wind forecasting. So when a power system operator is optimizing a power grid, they're always trying to strike this balance between electricity supply and demand, where the amount of supply going into the grid has to exactly equal the amount of demand coming, or amount of consumption coming out of the grid at any given time. And this problem becomes all the more challenging when you start integrating solar power, wind power, and other renewables whose output varies based on the weather. So there are a number of entities in the US, in the UK, for example, National Grid ESO is working on this, that are trying to draw on a combination of historical data as well as, say, videos pointed upwards towards clouds to try to get cloud cover information, and to try to combine this to try to create forecasts of solar and wind power that are kind of at a small spatial scale and also are near term, nowcasts as they're called. So forecasting is one general theme that emerges. Another is remote sensing. So transforming data from one form that we can't necessarily use for decision making, like satellite imagery, and transforming it to another form where we can. So for instance, using satellite imagery to track carbon dioxide emissions, which sure, they come from power plants, but also come from many diffuse sources like cars on the road. Trying to sort of track where these emissions are in order to get a better sense of where they're coming from, how many there are, and as a result, design, for example, better carbon taxes or carbon markets is something that is an application here. And there are a couple of entities, including a project between WattTime, World Resources Institute Carbon Tracker, who are working on these issues. Another satellite imagery application is, for example, tracking freight transportation. Freight and transportation are a huge percentage of greenhouse gas emissions, particularly in the UK, and yet there isn't always concrete data on where exactly those emissions are emerging from. So these are just some examples, but there are many more. So in addition to forecasting and remote sensing, there are themes across accelerated experimentation, trying to basically search through large spaces of next generation materials more efficiently so we can figure out, for example, how to better synthesize a next generation solar panel or create an alternative to cement. There are applications to optimizing systems, for example, optimizing agriculture to be more cognizant to the needs of the land and as a result not exhaust as many carbon dioxide resources there. And then also predictive maintenance applications, trying to fix infrastructure to avoid faults, for example, that would make an electricity grid inefficient ahead of time. Across all of these themes, it's important, I think, to keep track of where AI is actually going to be meaningful, but also where it may not be and where we have to be careful. And so there are a couple of challenges and questions that should guide deployment here. For instance, does this problem need a flashy solution? If you have an inefficient building, potentially you should just insulate it and then consider potentially integrating smart technologies on top of that. Making sure that the way AI is deployed isn't replicating bias or exacerbating inequities. So a lot of institutions with the most money and the most power are often the ones with access to AI, and that may in fact exacerbate then gaps between those who have access to these and those who don't. So there are a lot of just generally, there's a lot of necessity to basically be talking very closely to stakeholders who are working in climate change to be able to address these various challenges and ensure that the problems that are being solved are indeed ones that exist, and that ones where the various deployment challenges are considered. So then to just quickly get to Pete's question on how then, what are the applications for facilitating deployment before I then hand it off. So some of the things that can be done to actually facilitate meaningful deployment include fixing the gap between research and deployment. So on the entrepreneurship side, there often aren't clear markets or clear profit strategies for some technologies that come out of, for example, academic research that may be very impactful, but maybe are not profitable with a out of the box customer. And so creating these kinds of markets can actually be very impactful from a policy perspective. Similarly, you often hear there's a lot of money and a lot of funding in AI, but that funding is often concentrated in research institutions and technology companies. And yet things like municipal governments, who may be the ones actually implementing these technologies, may not actually have the funding to do that and to sustain those technologies. So bridging some of these funding gaps can be very impactful. Lots of things on the data side, which I believe the other panelists will be covering. So I'll put that there. And then finally, the development of impact assessment tools to help us figure out where we target innovations, where the low-hanging fruit is. And so when we talk about various applications, we can figure out how we kind of direct our capacity most effectively. So thank you so much, and I'll hand it off with that.
Priya, thank you very much. That was a fantastic start to the session. I'm going to hand over to Paul now to give an introduction from perhaps an investor's perspective, but also Paul has a lot of experience from the energy industry, from managing energy companies. So perhaps can bring that to bear on this question of how to accelerate the adoption of AI for climate change.
Great. Thanks, Pete. So what I would do is, building on what Priya was saying, I think what we're seeing is more and more adoption of this concept of digital twinning, where we are seeing essentially a physical network or a physical system that is becoming more and more hardware based. And because of that hardware, we're getting more and more data. And because we're getting more and more data, we can essentially create a digital twin. And you're seeing that whether that's electricity grids, whether it is transportation, whether it's health, whether it's weather, you're seeing huge amounts of data being produced. And you are therefore being able to start applying AI to begin optimizing that. And actually, as we look at decarbonization, the amount of money that's actually been spent on the hardware, whether that's being in terms of grids or solar panels or wind farms, is actually huge compared to where I think the money needs to be spent now, or in addition, which is essentially applying AI to a multiple of those systems. And what is more interesting is essentially each of those digital twins are beginning to essentially interconnect with each other. So you cannot look at the energy system now without thinking about the transportation system, whether that's electric vehicles or in the future hydrogen. You cannot look at the energy system and not think about the weather system, and you cannot thinking about drainage and floods without thinking about both weather and resilience. And so we are building piece by piece, essentially, a sort of digital world based on these digital twins of the systems we have. Now, many of those are at different stages and some are ahead of others. But I think that's the route map that we're going on. And as Priya said, I think there's many examples of where AI can be applied. The predictive maintenance, the optimization, the mapping, and the prediction of both use and deployment. But what I would like to say is that, you know, I've been investing in a number of AI companies. I've also been part of a creative destruction lab, which comes out of the US and Canada and is now at Oxford. And the last session we had was looking at AI. And in that, we had 26 companies coming through that were early stage, out of research. And many of those actually were very, very fundable, because essentially you are applying AI to a physical system already. And therefore, the acceleration of benefits made the payback very, very quick. And so, you know, that actually is very bankable. And in fact, a number of those people, at least I think 2/3 of the 26, ended up getting financed in some way. And so some of the companies I would just highlight, just to give examples: Habitat, which does AI machine learning for battery optimization into the grid, which essentially is a new market and is using both within day, the day ahead, and optimizing prices set against the chemistry of the battery. You have companies like iSize, which is using AI to manage bandwidth. So by using a very, very clever deep tech, it can reduce essentially bandwidth by 25 to 40% for video streaming into gaming, and all the carbon benefits associated with that. And then you have people like Grey Parrot, who you've had up earlier today, that we're looking at the screening of waste and waste management. There was another company called Zenenko, which looked at mosquito management, essentially using AI machine learning to separate female and male mosquitoes in order to reduce malaria. We've touched on solar forecasting, and I think the work that Jack Kelly and his team are doing at OpenReach are amazing. And then finally, I'll just say today that we delivered a report which was commissioned by the Committee on Field Poverty, which Deloitte has just written and released today, which is looking at how AI can be used for things like fuel poverty. So how can we use data mapped with health data and housing data to actually allocate funds in a better way? So I think each of those examples give you something that we're trying to do. So we've got a physical set of one data that we can match over with multiple other layers and start producing better insight and better execution data. And I think that's the real value. And because we can get there relatively quickly, then I think it becomes very financeable. But there are problems and there are barriers, without a doubt. So one of the reasons that we are seeing more people go into fintech or ad tech is the sense that they can't get the data of all these systems that we need to really impact climate change and the system. And that's definitely true in the energy system. And so we aren't necessarily getting all the people we need to where they should be doing the most important job in the world, essentially, which is helping us tackle the big issues. So some of the issues that we have are data sharing. So the concept of open data, and the Energy Data Task Force has done a lot of work at this on the presumption that all data should be open. Icebreaker One, I think now are just joining that work and looking essentially how you can set up data trusts. Then there are issues of governance and of privacy. So how do we manage the data? How do we know which data is available, which should be open, and essentially what is the level of privacy that's right? And so you can think about it as a grid. I might not want you to know my individual meter data, but actually at a subgrid point or a supply point, actually, am I that bothered? As it's an amalgamated data which is anonymized. And then finally, I think there are the issues of ethics. And as we enter into AI, I think it's very, very important that not only we begin to scope out the issues going into the questions that we're answering, but we also do regular checks on what are the outcomes, what are the models showing us, and actually, are we building in biases, or are we actually worsening positions? And I don't think it's a case of just looking at it once. I think it's a constant. And we need the governance frameworks there that allow independent people to review. So look, I think it's hugely exciting. I want people on this call to be thinking, hey, I really want to get into this space. I think I can finance it and I think I can make a difference. Because ultimately, this is the biggest challenge we face. Thanks.
Thank you very much, Paul. I'm going to hand over to Bryony Worthington now to talk about this question from her background and her experience, perhaps with a hint on particularly what governments can do to accelerate adoption of AI for climate change. Bryony Worthington.
Thank you, and you can call me Bryony, everybody. I only get called that in the house, and since we're not sitting, it's a very rare occasion. Hello, everyone, and this is a really fascinating panel that I was looking forward to today, and it's a vast topic, and we're not going to really be able to do it justice. But you'll have noticed in the previous speakers that we tend to think about the application of AI and machine learning in the energy space as our first kind of docking point on this topic, because of course it's our energy consumption that's driving the addition of greenhouse gases to the atmosphere. By and large, around 2/3 of the problem is the burning of oil and gas and coal for energy. And so naturally, a lot of the solution space around the AI and machine learning is around that topic. How do we optimize our energy systems? How do we make the most of we have an abundance of energy arriving or on the planet that's non-fossil, but how do we optimize that system so that it's able to meet our needs? Because it's distributed, it's a very different system to the fossil system we have today. There's a whole plethora of new areas of study on optimizing our energy systems and making them zero emissions, which is fantastic. The other third of the problem is how we use our land and how we manage our oceans, and the sort of biospheric component where we're adding CO2 to the atmosphere because of loss of tree cover or changes in land use, and then our agricultural system, which is contributing methane to the atmosphere. And then you've got some other, very highly polluting but very small amount of gases. So we've also got to be thinking about how does machine learning and AI contribute to that non-energy part of it, which is basically to do with our land use, our oceans management, and our food systems. And there's a huge amount to be done there. Now, across all of those topics, you'll find AI offering different theories of change and different tools to address those sort of columns, those thematic sources of the problem. And one of them, and Priya's touched on this, is instrumentation. We absolutely need more conversion of the real world into data. We rely on a bottom-up system of scientific research where public money funds research projects that go around the planet measuring different aspects of the change that we're experiencing and using that to help build models to project the future. It's not a top-down robust system. There are parts of that system which are well understood. The mixing of CO2 gases is an example where we have stations and we have weather stations, we have collection points, pretty understood. Methane, on the other hand, is much less well understood, and there are fewer data points, and it's a much less sophisticated monitoring system. So if we're going to use AI effectively to try and create that dashboard, that kind of control panel for planet Earth, we're going to have to make sure, first and foremost, we've got the right instrumentation, so we're gathering the right data. We're opening up those known unknowns and filling in the gaps of our knowledge. And that's true also of the impacts. So once you've got a better handle on where the temperature changes are coming, you'll want to be able to model better what are the likely impacts on our infrastructure and on business and on human lives ultimately. So there's a ton of research and work there around that whole the sort of meta problem of what exactly is happening on planet Earth, how dangerous is it, what's causing it, and what can we do about it as politicians and policymakers and citizens. So if you are sitting out there listening, thinking, what can I apply my wonderful tech skills to? This is a really important piece of the jigsaw. And that top-down process of making sure we're monitoring the right things, we've got the right instrumentation out there, is an area that really needs exploration. So if we take a step then down into the sources of the problem and the sort of national responses, or the multilateral responses to this, there's a UN treaty that's been signed, the Paris Agreement. Every country is seeking to reduce its emissions now as fast as it can, and that's where the sort of the optimization of energy policy and food and farming can have a huge role to play. But there's a problem, and the problem is that policymakers and who may be seeking change are up against some pretty serious headwinds. And by that I mean that we are lobbied. We are lobbied all the time because we are trying to change a system which is over 100 years old, which is lots and lots of people benefit from it. There's a huge amount of vested interest in the status quo. And it's not a blank sheet of paper. I might dream up a wonderful piece of legislation that requires a big shift in a particular sector fast, but it's not a blank sheet. There will be lots of politics that creeps in to then slow down that pace of ambition. And that the role that tech has played in the space of politics is extraordinary. I don't know if anyone caught Shoshana Zuboff's presentation about surveillance capitalism earlier today. The sheer amount of tech now that is able to track and trace our actions, influence our behaviors, influence the way we vote, influence the way we think. There's been this huge expansion of capability and data, and it's being mined, it's being used, and it's being very effective in promoting certain messages. We are all caught in a surveillance data-led system at the moment. Those of us certainly in the West are. How can we change that to a version of surveillance activism? And when we sit here today while we're watching a huge set of social upheaval in the US, and actually what I've found really interesting is the speed with which that activism, those protests, they've been able to coordinate, they've been able to create, it's a very creative process, this protest. And they're seeing change happening fast because the whole world has sped up. We all know what's happening across the planet far faster than we've ever done. Good and bad news travels at the speed of light, and we are much more able to coordinate ourselves through making connections. Now, all of that is enabled by machine learning and AI, and we've got to unpick and understand those tools, how they're being used, and then build them back and make them a force for good. So that's my sort of, stolen Zuboff's phrase of surveillance capitalism. I think we need surveillance activism, and that's got to be part of our mission when we think about how do we bring the worlds of climate change and the worlds of AI together. That it's about physical structures and the physics of our planet. It's also about the energy challenge and the food and agriculture challenge, but it's also about the challenge of politics. So those three very distinct areas where AI and machine learning have to be brought to bear on this problem, and we need to do it quickly, because as the title of today's whole conference is about getting the next 10 years right, we've seen a huge change in the last 10 years. We've got to now see a massive change for good in the next 10 years, where we get to that, we get as many greenhouse gas emissions out of the atmosphere as possible and start to give ourselves a chance of having a stable climate. I think I'll leave it there. I haven't said much about how we actually do much about this, but I'm sure in the questions we can dig into some of that.
Fantastic. Thank you very much, Bryony. That fits the bill perfectly. I think we're coming towards the end of the session now. And I'm just going to maybe push one final question back to Bryony around the speed of the change that you mentioned, because as you say, we're seeing ever increasing changes of speed and new technologies coming through. How can governments respond to that change of pace effectively? How can we create a similar agile response from our governments that we're seeing in the external world?
So, I mean, part of it is about, I know this perhaps is going to sound a bit controversial, but weirdos in Whitehall has become a phrase which is bandied around. But what that was basically saying, what Dominic Cummings was saying, was we've got to have public servants who can keep pace with this change. And the academia is one of the places where we are able to hold on to brilliant people who are able to keep track of some of this. There are lots of impact investment opportunities and companies that are doing good in the world, which also are able to attract and retain talent. But we need politics to be hearing from these people, and for those to be docking into the regulators and the lawmaking processes at timely moments. There's an inquiry going on at the moment in Parliament around the influence of machine learning and AI on democracy and social media and how it's affected democracy. That's been a call for evidence, and so we need, if there's no one out there that we can actually call in for evidence, if everyone's working for Facebook, it's not going to work. So we have to maintain an investment in salaried positions, institutes, research institutions that keep that brain's trust working in the public, for the public good.
Fantastic. Thank you very much. Thank you all for all of your perspectives. I think this has been a really interesting session looking at how we can accelerate the adoption of AI for energy and climate change. Some really interesting perspectives, really interesting opportunities. I'm going to hand back to Tabitha now before we move on to a Q&A session where you can ask further questions of our panelists.
Thank you very much. I felt like there was a little bit of a to-do list for me and others. That was a great session. Thank you. I just want to say good night to all of you watching on the YouTube stream. And those of you who are in the CogX app, please do head over to the Q&A. And it's your chance to ask those very interesting speakers some questions and maybe even make some suggestions. I feel like there is so much to discuss. So I will see you all tomorrow morning, bright and early. Thank you very much. Good night.
Want access to more CogX videos? Subscribe now for free at cogx.co.